Yeah, like you said, I work for Versus, and I know it's been a long afternoon probably, so you're just coming back, so I don't want to like overwhelm you, so I just want to, first I'd like to actually thank my fellow presenter, Adrian Cruz, for giving a great talk on metaprogramming, and also thanking him for now giving us a talk on metaprogramming that referenced another talk on metaprogramming. So, question for the audience, raise your hands. Has anyone heard of South Korea? Raise your hand. All right. So I was born in the United States of America, but I have South Korean heritage. My mother immigrated from South Korea, and over there they make a dish called kimchi, which is like a spicy pickled cabbage dish. Now making kimchi is pretty time-consuming by today's standards. It's something on the order of days, which in our days of fast food sounds like a lot. So I was thinking back on it, and if Mom had built a factory that had made kimchi, provided she had that much money, she could have saved some time. And if she had built a factory that built factories that made kimchi, she would have been meta-making kimchi. So this analogy is sort of the essence of metaprogramming, building a factory that builds a factory that does the thing you were trying to do by hand. And as other presenters have already said, you often hear this as writing code that writes code for your particular use case. So in this talk, we're going to go over a little bit about BDD. We're going to just give a slight overview of macros and metaprogramming. And then finally, we're going to dive into building our simple clone of the fun BDD framework, ESpec. OK, so what were my motivations? Well, originally it was just good old-fashioned curiosity. I was new to Elixir about, I don't know, year and a half ago. And there was this metaprogramming thing. And people that I actively respected, they discouraged me from doing it. That their first rule is don't metaprogram. To be fair, their second rule is metaprogram gratuitously. So when someone tells me, and especially if they're in a position of authority, like, don't do it, I just smell a rebellion, right? Like, that just makes me even more interested. So there you go. That's a picture of Jin Urso there saying, I rebel. So with that said, let's get into BDD. So what is it? In simple layman's terms, it's basically a practice where you specify the business behaviors the code should implement. In practice, typically this is done through a DSL, what's also known as a domain-specific language, a language written to deal with a specific problem domain. If you've come from the Ruby world, there's a BDD framework called RSpec, which ESpec is very much inspired by. And if you don't, Ruby is just an object-oriented, dynamic object-oriented programming language. This slide is just really to give you an idea of how it's done in practice. So you can just see there's a describe block, describe this subject. It has a name equal to John, and we expect the name to be John. So you can see it's very human readable, very friendly. It's like easy to specify our business behaviors, and that's sort of the essence of BDD. So now let's dive into macros and metaprogramming and how all this stuff works. So I think to understand metaprogramming, first you kind of have to understand the concept of an abstract syntax tree. So most languages you've worked with have an AST, but you're typically not aware of it because when your programs are compiled or interpreted, their source code is transformed into this tree structure on the screen behind me. It looks something like this. This is obviously just an image I pulled before being turned into bytecode or machine code to be run or executed. And usually, like I said, this is hidden from you. With Elixir, it's kind of nice because you can peer into the AST generated by macros by means of quoted expressions. So how is this sort of represented under the hood? Well, in Elixir, these AST fragments are represented in 3-element tuples. So the first element is an atom denoting the function call or another tuple. So in this case, here's a quoted math expression. You can see the multiplication call there. The second argument is metadata about that particular function or nested node. And the third argument is the arguments. So that's what it looks like under the hood. And the quote keyword ends up being a basic building block that you'll use when you're doing your own metaprogramming or encountering it in the wild. So now that you have an overview of abstract syntax trees, maybe it's time for just to give you an easy definition of what are macros. So as you've heard before, code that writes code or code as data. Thinking back to the kimchi analogy I made, it's factories that build factories that do the thing you're trying to do. You'll also might hear the phrase macro expansion, and what that basically is referring to is what a macro does. It literally injects that abstract syntax tree in place of the call during compilation. So the compiled code, once it's done, has no trace of your macro. It's all gone, there's no references, it's just good old-fashioned substituted abstract syntax tree that's returned during the compilation stage. I actually read recently, like metaprogramming stops after your binaries are produced. So like I said, quote and unquote are kind of our foundational go-tos, especially when you're learning it. So quote takes an expression and converts it into an abstract syntax tree without executing that code. Later on, you'll kind of see this more in action, but I'm just giving it to you now in basic form. And unquote injects values from outside that context. You can think of it like string interpolation is often the popular metaphor that's used. Best to see it as a quick concrete example. So here's a simple math expression, 2 plus n. We have our metadata tuple here with metadata and our arguments. Notice it's 2 and the atom n. So let's just try and evaluate it. I'm in the console, so I call this code.eval quoted to evaluate it. What do we expect happens? Well, actually, I expected it to be evaluated, but if you're new, you'll get this undefined function, which brings us back to what's going on. Especially, I ran into that when I was new. I was like, I don't get it. And then, of course, the answer is unquote, because it injects values from outside that quoted context properly. So again, if you look at your tuple here on the screen, you'll notice that arguments are 2 and 2 instead of 2 and n. And so when you evaluate it, you get the 4, just like we expect. So I think the other key takeaway, especially when you're trying to learn this stuff, is sort of thinking about compile time versus runtime and what happens. So macros run at compile time. So if you look at this def macro show message here, when I compile this in Elixir, you'll see this compile time message, see this value during compile time. What you will not see is this quoted expression at compile time. You'll instead see that at runtime. So I made this run module that imports the compile versus run. And so when I call this show message macro here, the compiler will replace that show message in the run start with the evaluated quoted expression. So just because I'm not brave enough to do live coding like some other people, I just made a terminal mock-up screen. You can see, which is apparently not displaying. But basically, let me see if I can get it to display for you really quick. But basically, if you, sorry about that. Okay, but basically what you will see on this screen is the compile time, oh, there it is. Compile time message if you try to compile it. And then if you do the run, you'll see the understanding at runtime, which is the runtime message that I was talking about. Okay, so now that we have all that in place, I also went looking for rules of the road, right? Like programmers just love these rules like solid and da-da-da, and like, so can we do that with macros? And it's like, and no, but we can find some nice guidelines. And I took these from Sasha Urich and Chris McCord, so some very authoritative people. So just some things to think about. Does the domain lend itself well to a natural expression by macros via our Elixir syntax? Would making a macro DSL cause the end user to think more or less about how to solve their problem? I'd argue for a testing framework that's isolated from your main code base. You're just trying to help your team write good tests, right? So you just want them to focus on writing good tests so they can ship the features out the door. And can I solve this efficiently at runtime, relying on the usual modules, functions, and all the other stuff? Then maybe it's better not to use macros in that case. And that comes from Sasha Urich. Okay, so now we sort of have some guidelines. We've talked about an overview of what's going on under the hood. Let's kind of dive into making our own BD framework so you can just see it done in practice. So here's our example, like ESpec, like very DSL. Like I said, I was making a very simplified clone of ESpec. If you look at the ESpec code itself, it's pretty cool. It's also somewhat complicated, especially if you're new to metaprogramming. So when possible, I try to do it the way the author was doing it, even if my use case didn't necessarily warrant it. So let's talk about defining describe. So you can see here on the screen, I'm using def macro to define a describe macro that takes a description. We're not going to really do much with it, and then here's the block of code, so all that context it stuff. And then again, you see the quoted fragment where I'm injecting the block of code. And this defines a macro with the name and the body, like I said. And if you think back to the previous slide with the context and describe, they kind of basically have the same structure, right? So it's actually a perfect candidate for dynamic function definition with macros. So let's use macros gratuitously, like Chris McCord says. And then what you'll end up with is on here, you can just see with the enum.each, I just made some, I made the context alias and then sort of another fake alias just to demonstrate the point. But I use the def macro keyword. I use unquote here because I want the actual value around that function. So it'd be context. I'm defining a context macro with, and then here you can see I'm using the describe macro structure, right? So I'm injecting that bit of AST and I'm unquoting the description and I'm unquoting the block so the AST expands properly. All right, so let's take a pause. Like I said, I know it's been a long break, so what just happened? Well, I'd say we avoided some boilerplate and we saw how to dynamically define macros. I sort of asked the audience to use their imagination. You can imagine like the more aliases you have and so on and so forth, if the functional clauses have similar structure but you want a pattern match, you'd be like context, context, context. Or if you want to add skip blocks like XIT, it'll be XIT, 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 rather than just like enumerating dynamically and defining it that way. So it makes your life a little bit easier. Obviously, some people would argue like, man, but it's a little bit harder to read. So, that, like I said, I never found solid rules of the road. It's kind of a gray area. So with that out of the way, let's dive out into building our assertions. So I just want you to keep this diagram in mind as we go through this. So this is essentially what ESpec uses under the hood to define assertions, like the B assertion that we're working on, like we expect 2 to be greater than 1. So what it does is it uses this interface macro. It injects this assert method into the assertions B module, and then it's basically an interface contract. So the assertions interface demands that your B assertion module define match, success message, and error message. If that's a lot to grok right now, just keep this diagram in mind when we go through the code slides. Okay, so like I said before, the whole point of the assertion interface is to provide a common API for the various assertions, be close to, et cetera. So, and one of the cool things that ESpec does is enforce this common assertion interface. So this best lets you, as the assertion creator, so let's say you want to create a different type of B assertion, it lets you specify when your assertion succeeds because you get to define how match is implemented, you get to define how the raise error message is implemented, and you get to define how the success message is implemented. And then you get to check it via the assert contract. It kind of reminds me of using gen server interfaces, to be honest. So since, and one other thing, when you use this using keyword, this just allows you to say use Padawan assertions interface in your module, and will inject all the stuff that you need. The other caveat is, okay, now that we know the B assertion code decides how it wants to evaluate, it does that via that assert method, we now say, okay, the assertions interface say we must define match and success message, and then down here, error message. So that's where this happens. You can see it's a pretty simple match, right? Because we're just doing a greater than or less than or an equal to comparison. That's what the B assertion is basically designed to do. And then jumping over to the expect function, basically we're just piping this value to the to function, but we actually return a tuple containing the expect to module and this value, which is 2 in our actual test case. And then ESpec does this style to take advantage of the common assertion interface macro we just built. So I think another reflection point, even when metaprogramming, use macros carefully. If you'll notice, there was no need for me to define the expect function via def macro, although actually I could do it, and it would have been fine that actually the tests do run. But Sasha Urich says potentially a good use case can be have macros combine your boilerplate to a single place to help with the readability stuff. Okay, so defining to. So this is kind of where I feel like some of the magic happens. So here's where we decide, okay, so we're piping this assertion and its arguments into the to module. And basically, you just call the assert method dynamically now. So you have the arguments, you have expect to and the value to. You have your assertions module, which defines match and success. And then you have your greater than 1 arguments. And you just pipe it here, and you call it dynamically. And so the beauty of that, you can imagine as you start building up more assertions, your to code doesn't really have to change, right? You just dynamically, in this one module, you say, all right, I'm defining an assertion. I'm just now responsible for deciding when the assertion success takes place. So I think that's kind of a nice isolation. I think it's it's just interesting to me, and I encourage you to like look at the code base to see that in action. Here, we're just importing the modules so we can get all our describe and context blocks. I want to point out this registration of the test attributes. Basically, this allows data to be stored at compile time. We'll see more of that when we get into the it block. And then I also want to point out the before compile hook. So this notifies the compiler that basically just do one more thing before compilation. And we'll see that in action in an upcoming slide. So this is the it block. Here is where I'm accumulating that data. And I'm basically going to use this line number and this function description I'm going to print it out later in the success message. So that's kind of the whole point of this. And then here on this def unquote, I'm basically just executing the assertion. So here is where the before compile comes into play. So I want to make a mixed test, so I have a run test method, and I want to run what's been accumulated in the @test module. Now, if I didn't have that before compile attribute, this @test would have been empty because of the way the macro expansion works. I have a repo where you can like comment it out and see this in action. So I don't think I'll like go into it too much, but that's kind of how it works. So all together. And so if you just go in and define the test runner, so now I'm passing that @test attribute. So all that stuff I accumulated, the line number, the function name, which I basically just atomize the description, and then the description. So I enumerate through that. I dynamically apply it to that module, of the Padawan module, and then I just print out a success message. And if luck holds, I will be able to say line 6, and then in that case, I print out the description, check success with 2 passing. So hopefully that gives you an idea of how to do macros in practice. So just some takeaways. Macros can be used as a tool to get rid of boilerplate code in your framework. Please use with care. Remember, especially when you're first learning, they're executed at compile time. Helpful to think about your end user. And for introspection and debugging, I just found this like _info. Kind of tells you on your module what macros or functions are defined. So if you get kind of confused, I think that could be helpful. Also, rolling your own test framework is a lot of work, so like, definitely stick to a simplified version. The end, there's some resources and how to contact me. Thank you.